Okay, we're going to go over calculating speed of a rotating wheel, right? So what I have here is a graph, and what we're going to do is they're going to show the graph kind of as a function. So I'm going to put some numbers in. Just give me a second. So we just found the graph of a Ferris wheel. Okay, there's a lot of information this graph is going to give us. We need to compare it to a circular object. Okay, because a Ferris wheel is a giant circle, what we're going to do here is we're going to actually create a small circle in reference to this, and we're going to use it as a reference point. Okay, now there's quite a few things I need to figure out on this Ferris wheel. First of all, I need to figure out where the axis of symmetry is, or the AOS. Do you remember how to find the axis of symmetry? Let's bring up some. Okay, so we brought up our formulas also. Okay, now the axis of symmetry, or in this case, sorry, I know I called it equation of the axis. Sorry, that's what we're looking for. Axis of symmetry is a parabola type thing we're looking for. So the equation of the axis. What are we looking for? Okay, so what would the peak be on this Ferris wheel? Yeah, our peak's going to be here at 18. Okay, and where's our trough going to be? 2. So, very important. In fact, I'm going to write the coordinates out of this. Okay, this would actually be 30 and 18, because our x is 30, and this one would be 90 and 2. Okay, we'll call this seconds, and we'll call this feet or meters. Either one's fine. Okay, so seconds and meters. So we have our peak and our trough. In order to find the equation of the axis, so the EOA, what's our formula say to do? Okay, so what do we add? 18 plus 2. 2. Okay. Yep. 20 divided by 2, which is 10. Good. So that's excellent. So what that means is we have a line going through the middle of this right at 10. Okay? So this is our middle line. Okay? Oh, good. So it goes on back. So we've got that. There's a couple other things we do need to figure out. We need to figure out how long a period takes. Now, a period, remember, is at our starting point, how long it takes us to get back to our starting point, and approaching it at the same angle. So we actually hit the starting point. What is the starting point on this one? 10. So they seem to start 10 meters in the air. So they must have some kind of ladder or stairs to get up there. Okay. Now, this Ferris wheel, when you're riding it, takes you up, and then you pass 10, and then you pass 10, 10, 10, 10. We actually pass it 1, including where we start. 1, 2, 3, 4, 5. We pass it 6 times. Does that mean this has 6 cycles, or a period is exactly when we pass it again the next time? A period, remember, is when we got to get to that same spot, but approaching at the same angle. So if we're instantly going up and then coming down when we hit it, is this considered one period here? No, a period would be getting through the entire thing, right? So let's make reference to this. Now, first of all, our equation of the axis 10, that actually tells us the middle of this Ferris wheel is exactly 10 meters above the ground. Okay? So what we're going to do is we're going to draw a little Ferris wheel line. There we go. So we know this Ferris wheel line here is 10 meters. Okay? So we know the middle is 10 meters above the ground. In terms of a period, okay, how long does it take for a period to pass? In this case, so you're saying from here to here is a period? This is one full rotation? Yeah, 120. This is where our whole period is. So at 120 is when we're crossing the number 10 on the same angle. If we had been coming up, this would have been the angle we're coming at, and this is our angle of ending. So it takes 120 seconds. So what that means is at our starting point, and remember we start at 10, say we start here, it takes how long to make an entire loop of this circle? Takes 120 seconds. So, let's talk about the seconds. At 0 seconds, I'm here. And then at 120 seconds, I'm here. Halfway around this circle, when I hit 10 again on the other side, how long would that take? That would take 60 seconds. Okay. What about a quarter of the way? What? Yes. And at 30 seconds, I'm at my what? What's it called on the graph? That's right. At 30 seconds, we're at our peak. And that makes sense in terms of the wheel, right? If we're going in this direction, we hit our peak at 30 seconds. At 60 seconds, we're at 10 again. So 30, we peaked. 60, we're here again. What about when I'm at the lowest point? Trough, yeah. How long did it take us to get there? 90 seconds. And finally, I get back to my beginning point again after 120 seconds. So one period takes 120 seconds, or 2 minutes roughly, to go around this Ferris wheel. Okay. Now let's talk about the number of cycles. How many cycles does this go through? We got one for sure. Does it go through another? Okay. Where's the next cycle end? At what time? 240 seconds. And then, here's a tough question. How much of a cycle is this? 3/4. Very good. 1/4, a half, 3/4. Ferris wheel ends. How high in the air are we when we end? You're thinking seconds. Height. Yeah, we're 2 meters above the ground, which makes more sense. You can probably get down from there, right? And it ends after how many seconds? 330 seconds. So what we're going to do on our wheel here with that information, because we wrote down our first axis, right? Now this height, how high is our peak here? How high in the air are we at this point? 18 meters. At this point, we're back at 10 meters. And at our lowest point, how high in the air are we? 2 meters. Good. Okay, so we found some information. We're going to write down the actual times here. So I'm going to move our equation of the axis over. And that way we can get all of our times in. So at 120 we're there. When's the next time I reach a peak? 150. And then the next time? At 180 we make a peak. When do we hit our peaks? Yeah, so 150 seconds, 270. So I'm going to write them all in here. Okay. We end our cycles, right, at 0, 120, and what's the other time? 40. Okay, so that's when we get back to our starting point. We re-hit our times at 60, 180, 300. So these are the times: 60, 180, 300. That's when we pass those points. And again, we're at our trough at 90, 210, and 330. Okay? So that's when we get to all of those. So we pass these all several times, which is good. So we found out quite a bit of information about this. We know that the rotating wheel is getting around. How long does it take this wheel to rotate? One full rotation. Now here's some important questions. Speed is equal to what? You know what the formula is? Distance. Yep. Over travel? Distance would be travel. Time traveling. How long it takes. Or in other words, they call it time. So distance divided by time. They usually write it like this. S is equal to D over T. Okay. Now, there's a couple of other pieces of information we need to figure out. First of all, if this is 10 meters in the air, and we need to figure out the radius of this circle, what are we trying to find on our graph here? What piece of information will tell us the radius of the circle? Yeah, and there's a specific name for that. That's called the amplitude. So we need to also find the amplitude of this. In this case, our amplitude is what? Amplitude is equal to, yep, divided by, which is going to give us, that's right. So our amplitude is 8 meters. In other words, it is 8 meters from the equation of the axis up to the highest point, right? So now that we know that, or same is to the lowest point, now that we know that, that's also considered the radius of this circle, okay? A very important piece of information. So from here to here is another 8 meters, okay? And it makes sense why the ground, here's we got our 10 meter here, another 18 is our height. So if we're trying to figure out how fast this wheel is spinning, this is a very important piece of information. We need to know the time, which we have. One full rotation takes how long? 120 seconds. So we got that piece of information already. So time is equal to 120 seconds. How do we figure out the distance of this circle? This is, what's it called? If it was a square or a triangle, how would I find the distance around this triangle? Do you remember what that's called? It starts with a P. Perimeter. For a circle, it's called something special. Circumference. We need to find the circumference of this circle in order to find the distance around. Now, circumference is equal to the radius times 2, so 2r pi. Okay. So we need to find r, which we already found. What is r in this question? 8. So in order to find circumference, or in this case the distance around something, circumference is equal to 2 times 8 times pi, which gives us 16 pi, which is, we're going to have to figure out, 16 times pi, 50.2, let's say. 50.2. Okay? And we're in meters here because we were 8 meters. So the circumference around the circle is 50.2. So, in order to figure out our speed, our distance is what? Our distance? Yeah. Multiplied or divided by 20. Okay. So we're about to figure out what our speed is. So we take our 50.2 divided by 120. We get 0.418. What has that told us now? 0.418. What's that number telling us? Because when we talk about speed, we talk about kilometers per hour, stuff like that, right? If I was to make this 0.148 a fraction, what would that be? What if I made this specific number a fraction? How would I make it a fraction? Put it above what? Put it above 1. So now let's write in some titles here. Okay. Remember, this was our distance in what? Meters. And this was our time in seconds. So, according to this is how I'd read it because the top is meters. I'm moving at 0.418 meters per second. Now, if they wanted to solve it every 10 seconds, it'd be a little different. But that's how fast this thing is rotating at. Okay? That's how we would be able to tell our speed. We put our measurements above it. So 0.418 meters per second. That's how fast this thing moves, which is about almost a half a meter a second. It's a pretty quick moving thing. So let's actually get an idea of what that means relative to what we're used to seeing. Right? We're used to seeing cars and stuff like that. What are car speeds measured in? Kilometers per what? An hour. Okay. So let's change this into kilometers and hours. Okay. So what that means is, first of all, how do I change seconds into minutes? What do I have to multiply by?
60.
Yeah. I'm going to have to multiply the top and the bottom by 60, right? So I can put every 60 seconds. How fast will we be going? Well, we'll be going 0.148 times 60. Well, we'll go 25.08 meters, right? So 0.08 meters every 60 seconds or every minute, okay? So we can put that back over 1 again, right? Because this was in seconds. Measure this one in minutes. So we have 25.08 over 1. To turn it into hours, what do I have to multiply by?
60.
60 again. So we multiply by 60 again. 60 on the bottom. 1,504.8 meters every what? Hour. Okay? So, does that seem fast? Seems really fast, but wait, am I measured in kilometers or meters? Oh, I'm in meters. A very different thing, right? So let's put this. This is 1,504.8 meters an hour. Okay? This is per hour. So this was in seconds, minutes, per hour. What is that in kilometers? What do I have to do to make that kilometers? Number. How many meters are in a kilometer? 1,000. So we divide by 1,000 the top. We're getting, we divide by 1,000, 1.5 roughly. So this is going 1.5 kilometers an hour. Is that fast? Not really. It's going actually pretty slow. Right? The meters is what will trick you. We've got to make sure we do that conversion again.